Okay, so we're going to begin working on our study sheet for pre-algebra Unit 3, modeling problems with rational numbers. The very first problem on the study sheet is talking about the greatest common factor, so we're going to go over that real quick. Just to refresh your memory, the greatest common factor will always be equal to or less than the smallest number, okay? So out of these two, we know our greatest common factor is going to be equal to 28 or less than 28, okay? So while we're on the subject, we're going to go ahead and talk about GCFs and LCMs together. Least common multiples will always be equal to or greater than the largest number. So if we were looking for the LCM of 28 and 60, it would have to be either 60 or something greater. Okay, so something like this, the LCM would be 60 or greater, the GCF would be 28 or less. Okay, since we're looking for the greatest common factor, I made factor trees. This is how I make my factor trees. I start with the smallest prime number that will go into 28. 2 times 14 is 28. Then the smallest prime number that goes into 14, 2. 2 times 7. 7 is a prime number, so we end the tree with 7 times 1. When you do your trees like this, you'll have all your prime numbers on the left. Okay? There are no composite numbers over here, just prime. 60. The smallest prime number that goes into 60, 2. The smallest prime number that goes into 30 is also 2. Then the smallest prime number that goes into 15 is 3. 3 times 5 is 15. 5 is a prime number, so we will end with 5 and 1. I like to end my trees with the prime number and the number 1. And as you can see, all of the prime numbers are on the left. Okay, so now let's circle for greatest common factor. You circle what they share. They share a 2, another 2, and that's all they share. They don't both have 7, they don't both have 3, and they don't both have 5. So the greatest common factor for 28 and 60 is 2 times 2, which is going to be 4. Okay, 4 is in our list of numbers right here. So we'll put 4 as the greatest common factor for 28 and 60. While we're on the subject, let's go ahead and find the least common multiple for 28 and 60. Remember that least common multiple is going to be equal to or greater than the largest number. You also need factor trees to find the LCM. Now, what you do after you make the factor tree is a little different. For LCMs, I like to do this part where I take the prime numbers and I simplify it. Instead of writing 2 times 2, I write 2 squared times 7, which really didn't save any time. Well, we won't go there. And then over here we have 2 factors of 2, so 2 squared, a 3, and a 5. Okay, for LCMs, you always choose the one that has the greatest of each factor. For 2, they each have the same 2 squared. So it doesn't matter, either or. This one has the greatest factors for 3 because this one doesn't have a 3. This one has the greatest factors of 5. This one doesn't have a 5. And this one has the greatest factor of 7 because this one doesn't have a 7. You use all the factors for LCMs. Sometimes some get left out because you had to choose between the two. All right, so let's write this out. 2 squared times 3, I'm just going in numerical order, times 5 times 7. Okay, so 2 squared times 3 times 5 times 7 equals 420. So as you can see, 4 was equal to or less than 28, and 420 is obviously greater than 60. That is the least common multiple for 28 and 60, and this is the greatest common factor for 28 and 60. Okay, on this problem, we have the plus minus combo going on here, and when you have that, it's just minus, no more plus, okay? Now we have negative 3/8 minus 5/8. Signs are the same, we're going to add. Remember, in fractions, you only add the numerator, not the denominator. So the numerator changes and the denominator stays the same. This reduces to negative 1, which is right here. All right, on this one, negative 1/6 divided by 1/2. Remember, in division, you always flip it's called find the reciprocal of the last fraction, and you change division to multiplication. We can cross cancel. This is a 1. And we're left with negative 1/3. All right, on this problem, they want us to find the solution for x. So we're going to do the opposite of multiplying x, the variable, by 0.5. We're going to divide it. That'll allow us to cancel it out. And when we do that on this side of the equal sign, we have to also do that on the other side of the equal sign. Okay, and that means negative 1 divided by 0.5. The answer is negative 2. So it will look like this. These are gone, you just have x. This becomes negative 2, which is right here. Okay, for this problem, the solution of 1/2 times m equals 0 is written right here. Since the variable is being multiplied by 1/2, we have to divide it by 1/2. And when we do that to this side, we also have to do it to this side. Remember, when you divide, this fraction flips and you multiply. So it looked like this. These cancel out, and you just have m equals 0 times 2 is 0. Okay, for this problem, I'm running out of space, so I wrote it here. And just so you know, you need to be writing this along with me on your study sheet as we work on it together, okay? When we have a negative fraction and a positive fraction, I like to put the positive fraction first and the negative fraction last. It just helps me solve the problem easier. When adding or subtracting fractions, you must have a common denominator. As you can see, these are not common, so we have to find the least common denominator for 3 and 6, which is 6. Remember, it's equal to or greater than the greatest number. Well, this time it's equal to the greatest number. So since this already has the right denominator, this is the only fraction that has to change. And to change it to 6, we multiply it by 2, and we must do that to the numerator also. So we have 5 and 2 6 minus 4 and 5 6. Okay, what happened here is now we have a numerator that's smaller than the numerator it's supposed to be subtracting. So to make this one big enough to subtract 5, we borrow from the whole number. All right, so that becomes a 4. When you borrow from a whole number, you don't just put a 1 in front of the 2, the numerator. You add these two numbers together, 6 and 2, the denominator and the numerator. So what you have is 4 and 8, 6. And that's how you got the 8. You added the numerator and the denominator. And 4 and 5, 6. Now you can subtract the numerators because this one's larger than this one. 8 minus 5 is 3. The denominator stays the same. 4's cancel out. 4 minus 4 is 0. So we just have 3/6. When you reduce 3/6, what do you get? That's right, 1/2. Okay, so write all this out, even if you have to do it on the back of your page. Okay, so 1/2 right here. All right, on this problem, we're dividing. And when you're dividing or multiplying, you don't have to have common denominators, which we do. Also, I don't worry about putting the negative at the end when we're dividing or multiplying. All right, when dividing or multiplying, you don't have to have common denominators, but you must have improper fractions. You can't multiply mixed numbers. So let's change these to improper. Oh, and that's negative. So I just went 3 times 2 is 6. 6 plus 1 is 7. 7 over 3. And then you just drop down the negative. Don't try using the negative when converting. And here I went 3 times 4 is 12. 12 plus 2 is 14. All right, remember in division, this changes and this changes. It becomes the reciprocal of that. Okay, we can cross cancel. All we have left is a 1 over a 2, and it's negative. All right, well, we're on this. The only answer that's left is -4. Does it fit this problem? What or which of these numbers is not a solution to this problem? This problem says x is greater than -4. 4 is greater than -4. -1 is greater than -4. -1/3 is greater than -4. -2 is greater. Remember, on the negative sides, the smaller the number, the greater it is on the negative. 0 is greater. All of these are greater than -4 except -4. So yes, -4 is the right answer for this problem. Okay, problem number 2. Maria solved the equation -4 1/8 times n equals -6 3/4. Her answer was n equals 237 over 41. She is fairly confident about her answer, but wants to do a quick check of her solution using estimation. Which of these show a good check for her answer? To estimate each of these fractions, I'm going to convert each fraction to a decimal, okay? Remember, all you have to do is divide the numerator by the denominator to get the decimal. All right, 1, 2. .12. All right, so this fraction is -4.125. 3 divided by 4 is 0.75. So this fraction is -6.75. 37 divided by 41 is 0.902. We'll round it to 0.902. Okay, so that fraction is 2.902. All right, as decimals, you can see what each of these will round to. This will round to 4, and it's negative, so negative. This is the only one with -4. We can find our answer now, but let's keep going. N is 2.9, which rounds to 3. And equals -6.7, which rounds to -7. So out of all of these, this one is the answer for estimating. Remember, estimate each fraction to find this answer here. Okay, problem number 3 says write -11/4 as a mixed number in reduced form. All right, what that means, 11 divided by 4. 11 divided by 4 is 2, so 4 can go into 11 twice, and you have 0.75 as a remainder. So it's going to be not be this one because it has a 1 when we needed a 2. And 0.75, do you know what that is? Well, let's just write it out real quick. So we have 2, 4 as our denominator. 4 times 2 is 8, so we need 3 as our numerator to make 11. 8, 9, 10, 11. 2 and 3/4. Okay, and we don't even have to reduce that. So here's our answer. -2 and 3. Okay, for problem number 4, which of the following is the graph of this inequality? -3 is less than n, or as I like to read it, n is greater than -3. All right, first let's discuss these circles. We have an open circle, and a closed circle. Why do they have open and closed? If your inequality signs are underlined, you will use closed circles. If they are not underlined, you will use open circles. So in this problem, we know we were going to use either this or this for our answer. Okay? Then the only difference is the direction of the arrows. Since the variable is greater than the integer, greater than means our arrows go to the right. Okay? So the only arrow that's going greater than is this one here. So problem 5 goes along good with problem 4 because it asks the question, to graph the inequality t is greater than 5, you would put an open circle on 5 and shade to the right. All right, remember, if the arrows are not underlined, then yes, you do use open circles. So that's true. Put it on 5, yes, because that's our integer. Are we shading to the right or left? Since t is greater than, just like this problem, yes, we will be shading to the right. So we can say that this is a true statement. Okay, problem number 6 says solve for t. Just like on our last unit, we wrote the steps down to solving equations like this. Or in this case, this is called an inequality because it has an inequality sign, not an equal sign for an equation. Okay, first we need to identify the variable, which is t. We need to identify what's being done to the variable. Well, this variable is being multiplied by a -3 and 6 is being added to it. Then to solve, we need to do the opposite of that. So we're going to be doing subtraction and division. Okay, always starting with the subtraction or division part first. We're going to subtract 6 from both sides. Forgot that side. Okay, 6 minus 6 is 0. All you're left with here is -3 times t. Over here we get -15 because when signs are the same, we add and keep the sign. Next step, division. Divide both sides by that -3. This becomes a 5. And then a tricky thing that happens in inequalities is whenever you multiply or divide both sides by a negative number, which we did, this trick happens here. The inequality flips. See, now instead of saying greater than, it's saying less than. Okay, and so all we have left is t is less than +5 because these two negatives made a positive. So don't forget that little trick. If you ever have to multiply or divide both sides of an inequality by a negative number, make sure you flip the inequality sign. Here we go. Okay, on this problem, we'll read Lewis needs to run at least 140 miles in order to go with the cross-country team to a summer training camp. He has 50 days to pre-train for the camp. Which inequality can be used to find how many miles Lewis must run each day to meet this goal? All right, the key phrase in this whole word problem is right here, at least. What symbol do we use for at least? It was discussed in one of your units. And these symbols, we just say less than, greater than, but they have other phrases. It could mean fewer than, below, more than, above. These also have other phrases. At most, no more than. At least, no less than. Okay, so you really should memorize this right here. And we see at least is this arrow here. So we will choose this answer here. Okay, for problem number 8, you're going to need to make a factor tree because they're asking for the prime factorization. Remember, with the factor trees, I start with the smallest prime number that divides evenly into the integer, which is 2, 38 times. 2 can go into 38 again. 19 is a prime number. If you know your prime numbers, at least the first few of them, you'll know 19 is a prime number. So nothing's going to divide into 19. 19, so we end with 19 and 1. So here are all the prime numbers for 76. 2, 2, and 19. 2 factors of 2, 19. Just like this one right here. Problem number 9 says 2 numbers have the prime factorization of that and that. Okay, which expression can we use to find their least common multiple? All right, remember with least common multiples, you choose the greatest of each factor. Like we did here, we chose the 2 squared, 7, 3, and 5. That one's not very clear because it didn't have very many doubles. Okay, so between these two, this one has the greatest of the factor 2, because this is only 2 with a 1. And this one has the greatest of the factor 3, because it has a 2 and this one only has a 1. Then you have your 5 and you have your 7. So what you have is 2 squared times 3 squared times 5 times 7, which is 4 times 9 times 5 times 7, which is 36 times 35, which is 1,260. Okay, remember that least common multiples are equal to or greater than the largest number. The largest, we didn't know what the largest number was. Anyway, that's why we did get a large number, but that's okay because least common multiples can be very large. All right, let's turn the page and see what our options are over here. We get more factors. So what we have to do is go through each list of factors and see which one gives us 1,260. Okay, I did the math for each one. And the only one that gave us 1,260 was this one right here. True or false? To graph this inequality, you would put a closed circle. Okay, yeah, that's right, because when it has an underline, you use closed circles. On -7, yes. And shade to the right. All right, well, our problem says that our variable w is less than or equal to -7. W is less than. This is false. This should be left. Because when it's less than, your arrow needs to go to the left. So this is false. All right, problem number 11. A carpenter has board of length 18, 24, 96. They must be cut into smaller boards of equal length with no scrap wood left over. What is the longest length of board he can cut? Okay, they're asking for the longest. They're asking for the greatest length. So they're asking for the greatest common factor of 18, 24, and 96. And remember, the greatest common factor has to be equal to or less than the smallest number. All right, the smallest number is 18. All of these are smaller than 18, so we can't eliminate anything from our list. We have to do the math. We have to do the factor trees. I went ahead and wrote out all the factor trees for the numbers using my way of starting with the smallest prime number and always ending with a 1, so that all the prime numbers are on the left side. Okay? Remember, greatest common factor, you circle what they share, like we did with this problem. They shared a 2 and another 2. So out of these 3 trees, they share a 2 across the board, a 3 across the board, and it looks like that's going to be it because there is no more 3s to share. So all we have is 2 times 3, which is 6. So the greatest common factor for 18, 24, and 96 is 6. Okay, for problem number 12, solve for x. Remember the steps. Identify the variable x, what is being done to it, and do the opposite. X is being multiplied by a fraction, 2/3, and it's also being added to 7. So we need to do the opposite of that. We need to divide and we need to subtract. Starting with the adding or subtracting step first, we're going to subtract 7 from both sides. That'll cancel out these 7s. And over here we have signs are the same, so we're going to add and keep the sign. Okay, next we're going to divide both sides by 2/3. Remember, in division, the division changes to times, and the second fraction always flips, or it's called the reciprocal. Oh, we got an x. These cancel each other out. All you're left with is x. Over here, we can cross cancel. And we have -10 times 3 is -30. And it's over 1, meaning it's just -30. Okay, I hope you're writing all this down. It's going to help you remember. All right, problem number 13. How much is 5/9 of -3/5? The word of means multiply. Remember that. Of means multiply or find the product. So all we have to do is multiply these two fractions. In multiplication, we do not have to have common denominators. We don't have mixed numbers. We're good there. So we can just go ahead and start cross-canceling. 3 can go into 9 3 times. So all you're left with is a 1 on the numerator. Well, it's a -1. And in the denominator, you have 3. And over here, the answer is listed right here, -1/3. Problem number 14, what is the solution of x? Here's another inequality sign, but you still have to do the same steps. Identify the variable, what is being done, do the opposite. The variable is x, it's being multiplied by 6, so the opposite of that is division. You're going to divide both sides by 6. Getting rid of this one, and this one becomes 4. Remember when the inequality flips? When you multiply or divide both sides by a negative. This is non-negative. So our inequality sign is going to stay the same. It's not going to flip on us. No flipping out. Okay, problem number 15 is a true or false. It says the mixed number, -4 and a fifth, can be written as this improper fraction, -19/5. Well, 5 times 4 is 20. Remember, do not involve the negative sign when converting. So it's just 20 plus 1 is 21/5. And then you just drop the sign. So this is false. It looks like they involve the negative sign while converting. You don't want to do that. You just want to add positives and multiply positives. And then you just drop the negative sign for your improper fraction. So this is false. Okay, on number 16, solve for D. So we identified it as D, not X. What is being done? It looks like it's being added to negative 23.7. So the opposite of that would be, of negative 23.7 would be to add 23.7. If you want to cancel out a negative 23.7, you need to add 23.7. So we're going to add 23.7 to both sides. 23.7 plus negative 23.7 is 0. And then over here, all right, that equals negative 24.87. Okay, problem number 17. 4 friends go to the movies. They split the total cost between them. The total cost is $17.05 for the tickets and $9.26 for the snacks. How much should each of them pay? First step, you're going to want to add the total cost, right? That's a smart thing to do. So total, they spent $26.31 that night. Now you can take the total cost and divide it between the 4 friends. And that'll give you $6.58. We'll round it up to 58. Each friend needs to pay $6.58. Okay. All right, problem number 18. What is the value of 11.68 minus 0.48 divided by negative 1.6? All right, remember there's always an order in math. Please excuse my dear Aunt Sally. Multiplication and division have to happen before adding and subtracting. So the first step is not to do the 1168, but to do the 4.48 divided by negative 1.6. Okay, and that answer is going to give us negative 0.3. So we have 11.68 minus negative 0.3. All right, looking at something like that gives us 11.98. And remember this, it actually becomes a plus sign. So that's why 1168 went up to 1198, because you were just adding 30 cents to 68 cents. All right, number 19, true or false? The prime factorization of 36 is 2 squared times 9. Let's go ahead and make a fact. The smallest prime number that goes into 36 is 2. The smallest prime number that goes into 18 is 2. The smallest prime number that goes into 9 is 3. 3 is prime, so we'll be ending with a 1. All right, so here's all the prime numbers for 36. 2 factors of 2 and 2 factors of 3. So as you can see, this is wrong. I could have told you at the very beginning it's wrong, because this is not a prime. This is a composite number. So it wasn't going to work. But I wanted you to work out with a factor tree and find out for yourself what the answer was. So this should have said 3 squared, and then it could have been true, but it didn't. So it's false. All right, problem 20. 3/4 of a number increased by 1/2 is equal to 14. All right, let's write this out with numbers and symbols. 3/4 of means times. Remember, a number is a variable, so let's use n. Increased by means add 1/2 is equal to 14. So our equation is going to look like this. Okay, remember with equations, you identify the variable, what is being done, do the opposite. I just realized I put an n here and an x here, so let's change that to n. Our variable is n. What is being done? Addition and multiplication. So to solve, we will be doing subtraction and division. First off, we're going to do the subtracting part. Plus a half minus a half equals 14 minus 1/2. 1/2 minus 1/2 is 0. And let's say $14 minus $0.50. What do you have left? You have $13.50. Think about it like money. We could change these all to decimals. If you know how to change the decimals, you can do that and solve. So this would be 0.5 and this would be 0.75. But I'm just going to work it out with fractions for now. Next step, division. Divided by, ooh, this one's going to be fun. We have to change that to an improper. All right, remember in division, the second fraction flips, called the reciprocal. Also in division, you can't have mixed numbers. You have to have improper fractions. So this is 27 over 2 as an improper fraction. This has to flip. I hope I did all this right. I don't want to have to rewind. Does 3 go into, yeah, 9 times 3, huh? Okay. All of that canceled. We just have the variable. That's right. When we cross-canceled everything here, we just got a 9 and a 2, leaving us with 18. So our answer, that's a lot of stuff to write out. But you better have that written out on your study guide. Okay, problem number 21. What is the greatest common factor of 18a cubed b and 36ab squared? Remember, greatest common factors are equal to or less than the smallest number. The smallest number being 18, we can cross out this as one of our options. All right, let's make factor trees for 18 and 36. Circle what they share on the prime factor side, which is the left side. All right, so the answer is going to be 2 times 3 times 3, which is 18. So the greatest common factor of 18 and 36 is 18. Luckily, there's only one 18. If there were more than one 18, let me tell you about the letters or the variables. For greatest common factors, you choose the smallest of the variables. So since this was A3 and just A, I chose that one. And between B and B squared, this is the smallest. So that's why we have A, B. For problem number 22, simplify. All right, I like to write the variables out in long version so you can see easier and just cancel things out. Because there are 2 factors of x, so I had 2 x's. There are 3 factors of y, so I have 3 y's. Okay. All right, I didn't do all the factors for 18 and 27 because I figured we could reduce that. We've done that enough times. We know that 9 goes into both of these numbers, so we reduce it by 9. And any variables that are doubled, you can cancel out. Okay? So what are you left with? 2 times x on the numerator. And on the denominator, you're left with 3 times y times z. Well, y times y becomes 3y squared z. So here's our answer, 2x 3y squared z. Okay, and then problem number 23. What is the least common multiple of 6a cubed b and 8ab squared? Remember that the least common multiple has to be equal to or greater than the largest number. So let's look at the largest number, 8. Well, all of these are greater than. So we can't eliminate any of the options. So let's make our factor tree. Okay, our factor tree for 6 looks like this. 8 looks like this. The prime factorization of 6 is 2 times 3, and the prime factorization of 8 is 2 to the power of 3. Circle the largest of each factor. Multiply that together, and you'll get 8 times 3, which is 24. So the least common multiple for 6 and 8 is 24. And let's go over the variables, because sometimes they'll have 24 on here twice with different variables. For the least common multiple, you choose the largest of each factor, just like you do in the factor tree for the number. So that's why it's a to the power of 3 and b to the power of 2 instead of a, b. Okay, that's the end of our study guide. Here's some things you need to remember about fractions. When adding or subtracting, you must have a common denominator. When multiplying or dividing, you do not have to have a common denominator, but you should always convert mixed numbers to improper fractions. Remember this, with your GCFs, your answer will always be equal to or less than the smallest number. And with LCMs, your answer will always be equal to or greater than your largest number. And practice making some factor trees and finding your GCFs and your LCMs.